Okay, welcome back, everyone. So first, we're going to be announcing the Corbett Ryan Pathways Pioneer Award. Pathways organization has a Pathways awareness program that strives to empower people who touch the lives of children by providing free information on the importance of early detection and intervention. Their goal is to help both parents and health professionals recognize and manage these early delays to help each child reach their fullest potential. So I would like to introduce to you Mr. Corbett Ryan to present the 7th Annual Corbett Ryan Pathways Pioneer Award.
Good afternoon. It is with great pleasure that I introduce to you the recipient of this year's Corbett Ryan Pathways Pioneer Award, Andrew McAleavey. He owns his own business in which he works with scientists and engineers to bring inventions to the public. These inventions have included prone and supine standers, as well as simulators to train to and prevent birthing injuries. In addition, Andrew is an avid rock climber. He also is a kid camp director at Ironworks Climbing Gym in Berkeley, California. I'm excited for him to share a story with us this afternoon. Ladies and gentlemen, let's give a warm welcome to Andrew McAleavey.
Well, thank you very much. I'm sitting up here and I'm very grateful for this. I'm very grateful to Corbett and the Ryan family. It's allowed me to come here and attend. I'll be also speaking a little bit later on climbing and exercise prescription in adults with CP. Whenever people comment on my attitude or what I've done in life, I always say, well, gosh, you should really be giving this award to my mother, because whatever attitude I have, good or bad, it was really, she was the one who inculcated it. But I think, and I've probably been in some of your sessions over the last day or so, and I've spoken up a few times, and I really think that a positive attitude and looking at CP in a positive way, they're critically important. And when I was younger, my mother was like that. She expected me to be a fully functional person and a member of society. She gave no quarter, and if there was something I couldn't do, she would make me find a way to adapt it. She would say, Andrew, take your plate to the sink, please, when you're done with it. And I would get up and, my plate would clatter and I wouldn't be able to do that. She said, well, Andrew, if you can't get up while you're holding your plate, get up, pick up your plate, and then go to the sink. It worked. In any case, since then, I've really enjoyed my life. I think that everyone with CP can enjoy their life and have fun and have a fulfilling time. And I hope that what we do here today and in the future can help people to think that way and to live that way. In any case, thank you very much.
Go.
Thank you.
Welcome.
All right.
Yep, no problem.
Yep. Safe carrying here.
Yes. Okay, next up is the Gayle G. Arnold Lectureship. So I'm going to introduce Linda Fetters. Linda Fetters, professor and Sykes Family Chair in Pediatric Physical Therapy, Health and Development, the Division of Biokinesiology and Physical Therapy, and Department of Pediatrics, Keck School of Medicine, University of Southern California. She directs the development of the Infant Motor Performance Laboratory, where her research focuses on very early intervention using discovery learning as an intervention and experimental paradigm. Dr. Fetters teaches development, motor control, pediatric physical therapy, and evidence-based physical therapy practice. She was named editor-in-chief of the journal Pediatric Physical Therapy, effective January 1st, 2016. Dr. Fetters is a Catherine Worthingham Fellow of the American Physical Therapy Association, the highest honor the association bestows on its members. She's taught and given scientific presentations throughout the United States, Sweden, the Netherlands, Tanzania, Taiwan, Japan, and Brazil. She was recently named a Fulbright Scholar to Australia for 2015 to 16. So I'd like to welcome to the stage Linda Fetters.
Ready to roll. Thank you for that introduction, Eileen. The Academy's chosen an excellent leader in President Eileen Fowler. I want to thank her for all the work she's done for this meeting and for bringing us all together. So thank you very much. I'm very honored to be giving this lecture named in honor of Dr. Gayle Arnold. I didn't have the pleasure of meeting Dr. Arnold, but from what I've read about him, he was an extraordinary pediatrician. The Children's Hospital Foundation of Richmond honors Dr. Arnold for his work with children and for his work with the Academy of Cerebral Palsy and Developmental Medicine, and we appreciate the foundation's support. The challenge of giving this lecture was to reflect on the opportunity to share my thoughts about development, children with cerebral palsy, and their families, and the state of the interventions that physical and occupational therapists offer during this window of time. Because, of course, this is a snapshot or a window in the state of our interventions, and it will be framed differently as more evidence accrues. I have had the great good fortune to see a transformation in the rehabilitation community from being a guru-led community to becoming an evidence-based community. I define evidence as including three parts, as Dr. David Sackett originally proposed. The three parts are research evidence, expert clinical practice, and parents' goals and plans for their children. Today, I emphasize evidence-based ingredients that I term green ingredients. It's my opinion about these ingredients that these ingredients should be included in all of our current motor interventions for children with cerebral palsy. While I suggest the ingredients are not necessarily sufficient, I do believe that they are necessary. What does it mean for an intervention to go green? When we talk about promoting action, what does it mean to have green ingredients? And what are the green ingredients? Today, as I said, I'm going to share my opinions with you, but I hope and believe they're informed opinions. They're informed from the current research literature, from discussions with expert colleagues, and from discussions and work with families and with children with cerebral palsy. The handouts that I prepared in preparation for this session on Saturday, Diagnosis and Intervention, that's in room 211 at 1:30, a little promo. Those handouts have research on each of the ingredients that I'm going to discuss this afternoon, a little bit of homework. This is certainly not an exhaustive list, but it is representative of the current research on intervention and concepts that support early intervention. I'm also going to describe some of the current research with infants that incorporate these green ingredients. But of course, like all research, they're going to need validation through further research, practice, and utilization by families. In 2013, Novak and colleagues published a review in Developmental Medicine and Child Neurology on the state of research evidence for interventions with children with cerebral palsy. I presume that many of you are familiar with this review. It created an enormous buzz. It was cited in many commentaries for the extraordinary contribution this team made to our understanding of the state of intervention, excuse me, and the state of intervention literature for children with cerebral palsy. This slide depicts a portion of that overall figure, one of the overall figures that's in the paper, in the review. The two columns of colored circles include outcomes of improved motor activities and improved function and self-care. These are two of the outcomes that were identified in the intervention studies that were included in this review, and there are two areas that I want to talk about today. Each of the colored circles, as you may know, includes the type of therapy that was included in the study, and the size of the circle indicates the relative amount of support, research support, for that intervention. If we look at the left side of the figure, there's a color-coded key for research outcomes. The green circles indicate that there was positive research support for the interventions within the circle. The orange circles above the dotted line indicate positive support for the intervention, but that if the intervention is used, the outcomes should be carefully measured and reported. The orange below the dotted line indicates less positive support for the intervention, and the red suggests that the current research does not support this type of intervention for the outcomes identified. Much of the controversy, and I'd suggest too much of the controversy, was in response to the red categorization of some of the intervention approaches. However, I'm intrigued by the green light interventions, and I want to focus on those green interventions today. What are these interventions, and what promise do they hold to improve the functional action for children? First, what are the interventions included in those green light studies? Constraint-induced movement therapy, goal-directed training, bimanual training, context-focused therapy, OT following botulinum toxin, and home programs. Second, are there characteristics of all of these interventions, and here I'm calling them ingredients, that are common and that might be essential or at least important for us to consider in all of the interventions that promote action? In addition to reading that literature, during the past year I've been working with a 6-member team to develop a systematic review of the research on motor interventions of infants and children under the age of 2 who are either diagnosed with cerebral palsy or at high risk. The Novak review included research, but mostly on older children. This international team has members from Australia, Kathy Morgan and Alicia Spittle, Canada, Johanna Dara, and the United States, Andy Gordon, Reggie Harborn, and me. I've had many productive discussions with this team and with many colleagues exploring our assumptions regarding the interventions that physical and occupational therapists provide for children. From this reading, discussion, and reflection, I'm suggesting common ingredients or green ingredients that we should all consider for our interventions, but specifically for the interventions for children under 2 years of age. Again, they're based on my opinion of the research evidence, but I believe it's informed opinion. First, I'll state the ingredients, and then I want to give you some examples of research that are using these ingredients. The first ingredient is early. Here I define early within the first 2 years of life. Make the diagnosis of cerebral palsy early and specifically, and then begin intervention as soon as possible. The specificity of diagnosis refers to our now much better understanding of the impact of the timing of specific events during gestation and early development and their potential developmental sequelae. Our interventions and our intervention research needs to take these early factors into consideration. Second, intervention should incorporate exploratory learning. Exploration through action serves mobility and functional action, but it also serves language and socialization. Third, there are specific ingredients in this exploratory learning that are important. The child should be an agent, literally a mover and a shaker. The child should make things happen in and to their immediate world and participate in the impact their actions create. But exploratory action is not meant to be without structure. It should include problems to solve, what we here refer to as the just right challenge for each child, variation of the problems, variation of the solutions, failures and time for failures, something very hard for therapists, of course, to watch, but then always some form of success, and lots of practice. Let's examine the first ingredient of early. There are two very real concerns that have hampered the early diagnosis of cerebral palsy. First, our concern is with false positives. The diagnosis given in the first year of life may be inaccurate. But Baird and colleagues published a study in 2000, and they identified that 86% of the 106 parents they interviewed knew that something was not right long before the clinical diagnosis. Of this sample of 106 parents, 42 indicated they were angry at the late diagnosis, particularly when they had raised concerns about their child and were assured that all was okay. Parents want to know early, and they want to do and be able to do something immediately. It appears that we need a little bit of a miracle, but a careful approach to these two problems is in the works. And it is somewhat of a miraculous endeavor, certainly for me to be able to see this in my professional lifetime. One group working on this early diagnosis issue is an international team led by Iona Novak and Kathy Morgan from the Cerebral Palsy Alliance Research Foundation in Australia. This team that I've listed here, to give you a sense of the diversity of people and the professions that are involved, includes 39 professionals, patients, and families that have completed a first draft clinical practice guideline with specific and evidence-based recommendations for early diagnosis under 2 years of age. The guideline will recommend specific diagnostic tools and specific timelines for best practice. I understand actually that after attending the meeting here that there are other groups working towards clinical practice guidelines for early diagnosis and that these groups have already begun to collaborate. Adopting and using an international guideline is a really important initiative in our understanding of the diagnostic process. And it affords us an opportunity to begin to intervene with interventions that have specific ingredients and then to measure if this approach has positive outcomes. And I say if this approach has positive outcomes in terms of improving functional abilities and the quality of life for infants and children and their families. Many of us make the assumption that early intervention should be supported because early infancy is a time of great flexibility and plasticity of the nervous system and indeed all systems. Much of the research on brain plasticity has been completed with adult humans and with other animals. While brain plasticity to support early intervention and interventions in general has research support, and it is intuitively appealing, empirical support for specific brain changes as a function of specific intervention has very little direct evidence from human infants. One reason is that this type of research requires longitudinal studies, sophisticated and valid brain and spinal cord imaging, and manipulations of environments that would not likely be approved by ethics committees. But the application of the concepts of plasticity directly to human infants, not only is it intuitively appealing, but it's been assisted by neuroscientist researchers such as Brian Kolb. Kolb suggests, and I have a quote here, Principles that underlie brain plasticity appear surprisingly constant across diverse animal systems. The developing infant brain is constantly creating circuits and new pathways, but after injury, the research of Kolb and others suggests that the developing brain is capable of creating novel neural circuits, unique neural circuits. And as Dr. Merzenak pointed out yesterday, these changes can be both positive and negative. We must be mindful. Here's an example of a mouse that was raised in an enriched environment that Kolb suggests will support and enhance motor development. He's a lucky mouse. He was raised in a very enriched environment. He was trained in a complex maze with many movement problems to solve, different problems that had varied solutions and lots of practice. He achieved success in exploring this environment and was rewarded with lucky mouse food rewards. Failures, successes, and rewards are important ingredients for our interventions to improve action. You'll see this clever lucky mouse solving complex problems that control mice who are raised in typical mouse environments. I'm not sure what that is, but lots of that sort of cedary stuff. Those mice couldn't achieve the complexity that you'll see this little guy achieving. Clever guy. Lucky mouse. This is the Tom mouse. The advantage to studying mice is that their brains can be immediately and inexpensively studied, although at great expense to the mouse. Mice raised in these environments demonstrate increased problem solving supported by increased synaptic connections and rich arrays of connectivity through their brains in comparison to the control mice. Kolb suggests that the application of complex housing with mice can be translated to the use of a wide range of games and activities to stimulate the human infant brain. The critical parts of these enriched environments is that the motor problems to solve need to be child-specific and provide what I refer to as that just right challenge. In a systematic review of the effects of enriched environments on motor outcomes for children, for infants under 2 years of age, Morgan and colleagues demonstrated a small but positive effect of enriched environments, but they urge, as all of the research with children under 2, urge more high-quality research and large enough sample sizes for studies to have the necessary validity to answer questions on the role of enrichment. The jury is really still out. In addition to the first ingredient, early, the second ingredient is that intervention should incorporate exploratory learning. Movements should be initiated and executed by the child, active movements. Eleanor Gibson was a preeminent developmentalist, and I was encouraged to hear her work used in research that was reported this morning. She encouraged us to understand the critical importance of exploration and discovery learning for healthy infants. Movement changes perception, which in turn affects movement in a constant perception-action cycle. Here I quote Gibson, "How learning occurs includes 3 principles, all dependent on perception itself. One is spontaneous exploratory activity, The second is observation of the consequences of exploratory activity. And the third is the selection of one of the variable means of exploration. We see examples of the rich processes of discovery learning as we watch exploring infants. I want you to observe how Abby, a 7-month-old, rotates the yellow plastic square that she grabs. And she lines up the break in the square precisely in order to pull it off. And notice her persistence.
And if your household happens to add a new laptop or e-reader, no worries. We'll have more than enough speed to go around. We even offer an advanced Wi-Fi router that increases the range of the Wi-Fi signal in your home from 65 feet to 100 feet and optimizes your file's quantum speed across all your Wi-Fi enabled gadgets.
Clever girl. Abby's exploration brings us to ingredients 3 and 4. Exploratory learning should include contingencies so that the child is an agent and makes things happen in and to the world. As I said, learning should include problems to solve, variations of those problems, failures, always successes, and lots of practice. We saw that in our lucky mouse, and we see this in our observations of the persistence and focus as children learn to master a skilled action. We likely underestimate the amount of practice incorporated into the development of skilled action for typically developing children. Aren't these adorable, typically developing children? They're my sons. No, I don't have children this age. They're now 35 and 32, but I promised them that I would use them in every talk I ever gave, so here they are. It also reminded me of the amount of practice that my husband and I did with our sons as we were growing up, doing the very many activities. Practice. From the elegant work of Karen Adolph, a developmental psychologist, and her colleagues, we've learned that the average toddler, these are astounding figures, takes 2,368 steps, travels 701 meters, the length of 7.7 American football fields, and falls 17 times in a single hour. Adolph extends this hour estimate to a multiplier of 6, assuming that that's about as much time as infants may practice walking. I don't know that they practice that much. This is a lot. But if you do that math, it means that infants take 14,000 steps daily. 14,000 steps. That's traveling the length of 46 football fields. It's a long way. And they fall 100 times. Practice indeed. I want to briefly present 4 interventions that are using the green ingredients that I've talked about. Early exploratory learning, specific characteristics of the learning, including problems, variation of problems, feedback, and the infant as agent. And of course, lots of practice. I'm introducing these interventions, and there are promising results from each of the interventions I want to show you, but they're pilot interventions. I'm going to detail the results of the interventions at our session on Saturday because there really isn't time to detail all, I think, what are important results during this talk. We've reported, and this morning Dr. Barbara Sargent reported this research as an example of exploratory learning, but I wanted to update Dr. Sargent's progress. She's leading a team of us at USC, and I have continued to find this really fascinating research. This is a laboratory-based intervention. It includes the green ingredients of early exploration, a goal or a problem to be discovered, infant as agent, and problem solving with failures and successes, at least for some of our infants. The infant is within a motion analysis system, and she has light-emitting diodes on her legs, and these are recorded so that we can later analyze leg motion and joint motion. The goal is for the infant to discover that by kicking in a specific place in space, she can make the mobile activate. She creates her own entertainment. The yellow circle on the left photo shows the LED that triggers the mobile when it crosses the threshold. Another goal is to increase the frequency of kicking and to encourage the selective control of the lower extremity. And here by selective, we're meaning the ability for the infant to produce movements, for example, relative flexion of the hip joint with extension of the knee joint. We define these coordinations through correlations of joint motions. We heard Dr. Merznick yesterday talk about the selective motion and the lack of selective motion in the rat pup who had its legs constrained. And I was particularly interested in their inability to make selective motion. And I know that Dr. Fowler is also interested in this. Infants who are at risk for developing cerebral palsy show delays in the ability to decouple, to create the selective movement in their lower extremity. And we were specifically planning this intervention for infants who are at risk for cerebral palsy. Hope you can see the red line. You can see the red line. The red line's not visible to the infant, but it represents a threshold that she set during the preparation or the baseline period that represents her typical kicking. And I want to show you her discovery of this mobile.
Twinkle, twinkle.
She's got it. This is a 2-day experiment. On the second day, some infants had learned that contingency, and some infants had not. Some infants changed their coordination pattern, and some did not. The next likely extension to the research was to increase the amount of practice. We could also change these place and space that infant kicked, but decided to increase the amount of practice for those infants who couldn't learn it. But a lab-based intervention is obviously not feasible or sustainable for most families, particularly in the vast area of Los Angeles. In order to provide sufficient practice to discover the contingency and improve coordination, Dr. Sargent developed a home-based system. With grant funds from Southern California's Clinical and Translational Science Institute pilot funding program, Dr. Sargent and tech-savvy colleagues used a Microsoft Connect system with a custom set of LEDs attached to the legs. The system and the mobile are controlled with a laptop computer. Let me play the movie for you. This is in this child's home. You may faintly be able to hear the sound isn't very good in this, but it's similar to. Thanks.
There was a farmer had a dog, Bingo, what? His name, B-I-N-G-O, B-I-N-G-O.
Barbara, I don't know how you've managed to listen to that music over and over again. I've been using it to practice for this talk. I hope I never hear E-I-E-O again in my life. This is a 6-week study during which parents use the system once a day for 5 days a week. On day 1 of each week, there's a 2-minute baseline period in which the mobile doesn't work, no matter what the infant does. After baseline, then there's an 8-minute acquisition period. When the infant crosses the established threshold, as you saw, the mobile turns and music plays. The next 4 days include 8-minute acquisition periods. It takes the parents about 20 minutes to do the entire intervention, including setup, 8 minutes of playing with the mobile, and cleanup time. And the system then remains set up in their home for 6 weeks. Data is preliminary, but it's actually very promising. And I know that you'll hear more about this in subsequent meetings. This is another green ingredient intervention that's been developed and led. A team has been led by Susan Duff. This was an initial pilot study. It was funded by a grant from the section on pediatrics of the American Physical Therapy Association. The intervention is now for infants with brachial plexus injury, but I know that Dr. Duff has plans for the future to use this with infants who have a hemiparesis. This little guy has a right-sided brachial plexus injury. And this particular intervention is focused on biceps activation because the biceps recovery and activity is predictive of long-term function for infants with perinatal brachial plexus injury. The intervention includes the green ingredients of early, exploration, a goal or a problem to be discovered, infant as agent, and problem solving with failures and successes. The infant sits in a chair in front of a computer monitor. She wears EMG sensors over each biceps. Here they're covered with black cuffs. When the biceps contract, a signal is relayed through a laptop computer to activate a video. We assumed, and I think correctly, that the infant would want to keep the video playing and continually contract the biceps. So when the biceps is contracted, here's an example of what the infant hears.
When you wanna do something that's new and it seems really, really hard to do, you feel like quitting, you feel you're through. Well, I have some advice for you, don't give up. Keep on trying, you're gonna make it. I ain't lying, don't give up.
Barbara, can you put that in the mobile, do you think? So Bruno Mars' words are probably a little advanced for the infant, but it kept the researchers going. And the biceps contracting. So we pilot tested it. Sue gave a poster session yesterday of the preliminary results. I'll show you a typical infant's reaction and then a child with the biceps brachial plexus. So I think we have a winner there, and a lot of contracted biceps. Another example of intervention for infants using green ingredients is from the work of Kathy Morgan. She'll detail this study and the initial results in our workshop on Saturday. I mentioned that we were doing a systematic review. We found 34 studies for that systematic review of work that was done with children under 2 years of age who either had CP or are at risk with having CP. This is one of the few studies that had positive results and that had these green ingredients. In this particular game project, the child is an agent. The environments are enriched, lucky children. The movements are varied, the movements required are varied, there's varied problems, and there's lots and lots of practice. This is the last intervention I want to share with you today, and it comes from the work of Cole Galloway, who's generously shared his work with us and with many others. It's really been expanded and put forth by Stephanie Yu, who's a physical therapy manager in the California Children's Services in Los Angeles. She's worked with Cole, and they've shared these videos with me. These are store-bought plastic ride-on cars, and they're modified with trunk support and a manual switch that the child can control to move forward. The infants and the child discover that they can propel the car by hitting the switch, and I'll show you the little video.
Come on!
Yeah. That's loud.
Back too far. Come on! Go get her!
There you go.
I'll stop the video before she hits the car, because she does. It's all a part of learning, right? All right, in summary, we can identify key ingredients that should be included in intervention for all infants and children with cerebral palsy to promote action and function. There are many different ways to use these common ingredients in order for children to achieve positive outcomes. As I mentioned at the beginning of this talk, this is a window of intervention. This is a window of time for intervention. We must act to support children and their families, knowing that our recommendations will change over time. As long as we continue to use the best available research evidence, we can feel confident that we're offering our best. Rather than naming our interventions for people or places that become fixed, if we use the acronym BEAR for all of our intervention and used evidence-based interventions, then we are acting responsibly and wisely. In an article on evidence-based management, Pfeffer and Sutton from Stanford University define wisdom as acting with knowledge while doubting what you know. Thank you.
You bet. Fun? Great. Yeah, thank you very much. Sit up here. I'm going to show me the questions. Sit this way. Yeah. Okay. So I want to thank Linda very much. What's beautiful about the work that she presented is it really brings some of the rich information from the fields of motor learning and motor control into trying to treat children that are at risk for cerebral palsy. So next we're going to have the Gayle Arnold Award presented, which is one of the Academy's most prestigious awards, named for the late Gayle Arnold from Children's Hospital of Richmond, Virginia. First, I'm going to tell you a little bit about Dr. Gayle Arnold. He was a long-time practicing general pediatrician in Richmond who was medical director of the Richmond Cerebral Palsy Center. He was also a past president of AACP-DM. The Children's Hospital Board of Directors provides funding for an eminent presidential guest speaker and scholarships for trainees to attend the annual meeting. Dr. Arnold was honored as a daily point of light by President Bush as part of a White House program encouraging volunteerism. Dr. Arnold was a graduate of Johns Hopkins University and the University of Maryland Medical School. And is Dr. Monasterio here in the audience at all? Could you please come to the podium to present this award to our winner? And then she's going to give a brief talk, which is a winning talk from last year. And it really dovetails very nicely with Dr. Fetters' work that her talk is next, as you'll see when you listen.
Thank you. That was bring me up to take my picture. The Gayle Arnold Award goes to Alicia Spittle. The paper titled Neurobehavior at Term is predictive of neurodevelopmental outcomes at 2 years of age for children born moderate late preterm.
Thank you, and thank you very much to the Academy and to the Awards Committee for this award. I feel truly privileged to be receiving this award. I'd also like to thank my colleagues who worked with me on this research who are listed here. I have no conflicts of interest to declare, except that I did receive funding from the National Health and Research Council of Australia. Depending on where in the world that you're born, 5 to 15% of babies come early, that is less than 37 weeks. And worldwide, that accounts for 15 million births per year. We know that infants or babies who are born very preterm, so less than 32 weeks gestational age, are at high risk of having developmental impairments. But also of great concern is that moderate to late preterm infants are at risk as well of developmental problems, and they actually account for 80% of infants who are born early. We know that infants who are born moderate to late preterm have poorer brain growth and maturation compared to their peers born at term on MRI. However, doing MRIs on such a large number of children is not practical, and identifying which moderate to late preterm children require developmental surveillance and early intervention remains a challenge for clinicians and researchers. And therefore it's important to have other clinical indicators to identify which infants born moderate to late preterm are most at risk. Neonatal neurobehavioural assessments offer an insight into an infant's strengths and their vulnerabilities. They offer ability for parent education, targeting follow-up services to those most at need, and referral for early intervention. We know that infants who are born preterm have, compared to infants who are born at term, have poorer flexotone, poorer quality of movement, poorer self-regulation, orientation and arousal. We know in infants who are born very preterm, so infants born at less than 32 weeks of gestational age, that neurobehaviour at term is predictive of later outcomes, but this is a very high-risk group. We don't know in infants who are born moderate to late preterm who are at lower risk whether these neurobehavioural assessments are actually predictive of longer-term outcomes. So the objective of this study was to examine the relationship between neurobehaviour at term equivalent age, so when the baby was supposed to be born, and neurodevelopmental outcome at 2 years in a prospective longitudinal cohort of infants born moderate to late preterm. We recruited 201 infants who were born between 32 and 36 weeks, and you might ask why we recruited 201 as opposed to 200, but when we went to recruit number 200, they were a twin, so we recruited both of them. And at term equivalent age, we assessed the infants using 2 neurobehavioural assessments, the Hammersmith Neonatal Neurological Examination, which was created by the Dubowitzes at the University College of London, and that involves 6 subscales and a total score, and it has more of a neurological focus and is a very clinical, easy exam for anyone to do. The NICU Network Neurobehavioural Scale is a bit more complex exam. You do need to be certified, and it's got more of a behavioural focus and has 12 different subscales. And for both examinations, we used we classified the infant as suboptimal if they performed below the 10th centile relative to a term reference group that we recruited from our hospital as well. We then assessed their development at 2 years of age at our hospital, or if they weren't able to make it into the hospital, we did do home visits, and we used the Bailey scales of infant and toddler development and looked at cognitive, language and motor development, and they were classified as having a delay in one of those particular areas if they performed 1 standard deviation below the mean. Again, we had a term reference group for this. We then looked at the relationship between those early neurobehavioural exams, with looking at all the different subscales and delay at 2 years on the Baileys, using logistic regression. We then repeated our analysis, adjusting for age at term assessment, social risk status and sex, because we know that these are also predictors of development. So as I said, we recruited 201 infants at birth. We then got 187 infants back at term to do the 2 neurological examinations on them. And at 2 years, much to the credit of our research nurses, we had 97% follow-up and saw 197 infants with the Baileys. You can see the characteristics of the population here. The mean gestational age was 34 weeks. Their mean birth weight, 2,160 grams. Approximately half were male and almost 40% were multiple births. Oops, sorry, can't go back. Right goes back, sorry. So you can see here the results were initially for the Dubowitz, the HNNE, and what we can see here is that overall, wrong way down, that 26% have suboptimal performance on the Dubowitz examination. When we look at the ends, you can see that there's a lot more subscales here, but compared to infants born at term with 10% having suboptimal performance, we can see that for those infants born moderate to late preterm, that they have much higher rates of suboptimal excitability, lethargy, regulation, arousal, stress and quality of movement. And then at 2 years on the Baileys, we found 19% of the moderate to late preterm infants had a cognitive delay, 36% had a language delay, and 42% had a motor delay. And so then if we look at the relationship between the two assessments, and just to orientate you to this figure, the circles indicate the odds ratio and the lines indicate the confidence intervals. Anything on between 0 and 1 means that if you have a suboptimal performance, you have a reduced odds. Anything that is above 1 means that you have an increased odds. And what we can see is any of the if you had suboptimal performance on any of the items, you had an increased risk. But when we look at the significance, we can see that if you have suboptimal movement, abnormal signs, behaviour, or total scores at term, you had a significant increased odds between 2 to 3 times of having a cognitive delay at 2 years. However, once we adjust for age at term assessment, social risk and sex, you can only see that behaviour and the total score on the HNNE are predictive of cognitive delay, but it's associated with a 2-fold increase in cognitive delay. If we then look at language outcomes, we can see that only the abnormal signs were related to language outcomes at 2 years, but once we adjusted for the same factors again, this no longer remained significant. And interestingly, there was no relationship between the HNNE subscales and total score and the motor composite on the Baileys. If we then go to look at the ends, and as you remember, there's a lot more items here, but we can see there's mostly a suboptimal performance on the ends is related to cognitive delay at 2 years, but we can see that there's a significant relationship here between excitability, lethargy and regulation. And again, when we make those adjustments, we can see that excitability and regulation are predictive of cognitive delay at 2 years with a 3 to 5-fold increase. And there was no relationship between the ends, subscales and motor or language composites. So some of the strengths of our study was that it was a very large prospective cohort trial. We had local normative data to compare our results to, which has been a particular problem with some of you will know with the Baileys. We had excellent follow-up rates and we had blinded assessors, but we do need to remember that these is just looking at the association between term examination and 2 years. We're not actually looking at diagnosing infants with a cognitive delay. But what we did find in our study was that 2 neurobehavioural assessments at term equivalent age in moderate to late preterm infants are associated with cognitive outcomes at 2 years of age, particularly the HNNE behavioural scale and total score and the ENDS excitability and regulation subscales. And there was no relationship between neurobehaviour at term and motor and language outcomes. This has important clinical implications because neurobehavioural assessment tools, which are low-cost, non-invasive method for early detection of infants at risk of cognitive delays, and particularly in infants who are born preterm, there is very strong evidence from Cochrane reviews to show that early intervention actually does improve cognitive outcomes for these infants. So finally, I would like to thank the rest of our research team. We've got a fantastic multidisciplinary team who have disappeared, and also like to thank our funding bodies and also our families who participated in this research. Thank you very much.
Oh, another photo.
I should put mine. I think so.
Okay, so next we have what we're calling a hot topic. So this was from an instructional course that was held last year that generated a lot of interest, and it's an area of research that also might have a little bit of controversy because sometimes these areas of research where the practice gets ahead of the research. So we wanted to invite these 2 speakers back to have a more broader audience on this topic this year. So I'm going to invite both our speakers to come up to the table while I introduce them. So the first speaker is Kathleen Friel. She's assistant professor of Department of Neurology and Neuroscience at the Weill Cornell Medical College in New York. She's director of clinical laboratory for early brain injury recovery at the Burke Cornell Medical Research Institute in White Plains, New York. She's director of cerebral palsy research at Blythedale Children's Hospital, and her research aims to improve hand function in children with cerebral palsy by understanding the neural underpinnings of motor dysfunction. Her research focuses on the importance of motor activity in neurorehabilitation. Her laboratory uses non-invasive brain stimulation to study motor circuits that are important for rehabilitation. Our other speaker is Bernadette Gillick. She is an assistant professor at the University of Minnesota School of Medicine, Department of Physical Medicine and Rehabilitation, program in physical therapy. Her research surrounds cortical plasticity and recovery from neurological insult in pediatric populations. Her research encompasses applications of non-invasive brain stimulation, neuroimaging, and rehabilitation for improved motor function. Welcome.
Thank you. So we can pull it from here, correct?
Yes, and so this is right.
Thank you. Thank you very much for the honor of being here. I am Bernadette Gillick. I will be speaking in conjunction with my colleague Kathleen Friel, so we'll tag team here today. But Dr. Fowler, thank you for the honor of being here and speaking. So when we were choosing the topic on how to frame this title, it reminded me of a quick story in something that just happened to me last year. We have a neuroscience colloquium series that we go to bi-weekly, bi-monthly, I should say. And one of my colleagues said, "So how's your research going, Dr. Gillick? What have you been up to lately? I know you've been doing some things in non-invasive brain stimulation." And I said, "Oh, I have, actually. We have a clinical trial running, and we are doing pediatric stroke and non-invasive brain stimulation in conjunction with constraint-induced movement therapy." And he said, "Well, that's fantastic. Rats or monkeys?" And I said, "Humans." And he said, "Human children? Human pediatric, you mean human children?" And I said, "I think it's time. I think it is time. And I think it's time that we translate some of these things, but safely so." And it made me think of what we are talking about here today in terms of stimulating controversy as we stimulate the brain. And what is this concept of disruptive change agent? We have these disclosures in terms of our funding agencies, both myself and Dr. Friel, who is here, along with our collaborative institutions, both of us. So a disruptive change agent is a term that's used, and many of you are familiar with this, in terms of what is happening in the marketplace. And it can be a different way to problem solve. It might be something that's not tried before. Perhaps it's radical and new to the field. And typically it's disruptive. And in this manner, disruptive might not be coined as a negative thing, but actually might be something that disrupts and creates positive change. This innovation theory, disruptive innovation theory, was advanced by Christensen in the 1990s, but has been around for centuries in terms of something new and something radical that might push change. If, for instance, there is a major disruption in the market, a manager may perceive that disruption and somehow influence what the action of the business will be, or the company. They may have a specific organization or response, and they may also allocate resources in a specific way. If the disruptive agent, the change agent, is perceived as a threat, there might be a speedy overreaction or an even overcommitment of resources in that domain. If it is perceived potentially as an opportunity, there may actually also be an undercommitment of resources and too soon an adaptation of whatever that change agent may be. So leaders in business need to think and act differently in order to chart a new course for the enterprise. These are, I am sure to many of you, familiar disruptive change agents that are out there today. The concept of the Amazon drone dropping off packages, the concept of Airbnb, and many of you I know are staying at Airbnb here in Austin, as opposed to staying in the hotel. The concept of Netflix, who came along and challenged as a change agent Blockbuster, and the concept of going in and renting films versus being able to do that online. And then also the concept of Uber, as opposed to using taxi systems. All of these are disruptive change agents and can be perceived in different ways. In the field of medicine and in the field of rehabilitation, we have our own disruptive change agents. So here we're talking about the polio vaccine, the 1950s, and how Jonas Salk was able to achieve quite a thing, and in that time was perceived as radical all the same. So this incredible disruptive change agent that eradicated the polio and brought a vaccine to light also was perceived as radical in and of itself.
Another is more recent adaptation and adoption of telemedicine. So in this title, internists emphasize the importance of balancing benefits against the risks for their patients. And now policy recommendations are being made, and specifically position papers are being written on the use of this. I would also add, as per a recent discussion with some of my colleagues, that another disruptive change agent is right at the heels of telemedicine in terms of the use of FaceTime between patients and their healthcare providers. Another example of this is deep brain stimulation for patients with Parkinson's. This still, even though this was adapted and actually approved about 20 years ago, this still can be perceived as a problem in terms of some of the outcomes and some of the lasting or long-term effects that this may have. So we heard actually from Richard Ellenson from the CP Foundation yesterday that a child with cerebral palsy is born every hour. So even with all of these therapies that we have been discussing, these incredible things that I've been hearing and hear every year when I come to this conference, have we made big leaps in improving outcomes in cerebral palsy? It's a question I know we all ask ourselves. There is a ceiling of maximal improvement, and we need somehow to reach it and break through it in terms of maximizing the outcomes for people with cerebral palsy. We balance these concepts, and many of you spoke about this even this morning, between safety, feasibility, and efficacy. And I would argue that safety is at the forefront of the majority of the researchers who are looking at non-invasive brain stimulation and the applications and translations specifically to the patient population. In our world, patients who are children and children with cerebral palsy. And there are others that are out there saying the same in terms of pleading for caution, pleading for ways that we can improve how we are investigating this, and not, as Dr. Fowler mentioned, accepting this outright, looking at this disruptive change for what it is and what it may be. There are two forms of non-invasive brain stimulation that I will talk about today along with Dr. Friel. One of them is transcranial magnetic stimulation. The other is transcranial direct current stimulation, and I'll use those acronyms as we speak. So if you look at these two, one can be used to investigate brain physiology. That's TMS. And it can be used in a way through single pulses or other designs to understand what is the cortical excitability of the brain, for instance. How is the brain potentially reorganized? How is the brain organizing around a stroke, for instance, in a stroke and cerebral palsy? The other means by which we can use non-invasive brain stimulation is to modify the physiology, neuromodulation, and the performance of an individual. And using TMS repetitively is one of those ways, and using also TDCS can be another. I'm going to hand the podium over here to Dr. Friel to speak some to the scientific evidence that is behind our work.
Thank you, Dr. I'd like again to thank Dr. Fowler and the Academy for this opportunity to present on this topic. I'm here to discuss some of the scientific evidence behind brain stimulation and what we can learn about how best to apply brain stimulation to children from what we understand from an animal model of cerebral palsy. So we know from much work as highly as trained dogs that activity is essential for development of the motor system. And we know that activity provides essential cues that guides development. Activity can also reshape the vulnerable or damaged motor system. And I will discuss today providing activity either through training or through exogenous stimulation. Together with Jack Martin at Psychologist New York, we've studied a cat model of MSPT cerebral palsy. In this model, we block brain activity by infusing a drug that silences the brain during a critical period in development in cats. These cats show lifelong deficits in motor skill, and they show maladaptive reorganization of motor pathways that connect the brain and the spinal cord. And these aberrant pathways underlie the pathology of cerebral palsy. Our work has shown ways to restore motor function in the cat model of CV through exogenous stimulation and motor training. In both of these studies that I will present, I'll discuss motor skill and how the organization of motor pathways changes with therapies. First, I'll discuss a study that was led by Dr. Arnold in Japan's lab, in which she implanted an electrode in the motor pathway of cats after they had acquired cerebral palsy. They received stimulation for 2.5 hours a day, 5 days a week for 4 weeks, as developing kittens. We looked at how this stimulation affects the motor skill of cats. One of the tests that we use to measure motor skill in cats is having them walk across a horizontal ladder. A normal cat will walk very quickly and very easily, but a cat with cerebral palsy will often overstep the rungs and even fall through the rungs. This graph to the right shows how much cats overstep. The light gray bar shows cats who have CV, and they overstep much more than a control cat. But the cats represented by the right bar that receive stimulation overstep the same as a cat without cerebral palsy, so we restore motor skill in these cats. Another paradigm that we've tested is constraint-induced movement therapy. Now, I've heard many talks about constraint therapy in kids, and so we've actually done this in cats as well. We restrained the unaffected limb for most of the day, all but 1 hour, and during that 1 hour, some cats received training on a skillful task. Cats were trained to reach for food pellets, which they'll reach for all day if you let them. And in week 1 to the left shows a schematic of the cat's paw reaching to the reward, which is the white dot. And the rainbow type drawing on the bottom left shows where the paw reached during each trial. So you can see during week 1 of therapy, they were not very accurate. But after week 4, they were very accurate. We also looked at how stimulation or training can reroute the motor pathways. So this shows a schematic of the spinal cord. And in cats without CV, the motor terminals end up in the medial intermediate zone of the spinal cord, shown in the red outlined rectangle. In cats with CV, the pathways terminate in a dorsal area, which is not the normal motor area, but in cats with stimulation and training, the connections again find their way to the normal, appropriate connections. So, how does this translate to what we can do to help children with cerebral palsy? Here I would discuss a study that we've done in collaboration with Andy Gordon at Yale University, Andy's at Teachers College, Yale Kids Autism, and we looked at the neural correlates of bilingual therapy in kids with hemiplegia. We know that training is essential to therapy, and there's a bunch of evidence that bilingual therapy improves hand function in kids with cerebral palsy. So kids in our program received 90 hours of intensive therapy in which they played games and performed functional and fun tasks that really engaged hand movements. We looked at which brain regions mediate recovery in these kids, and here we use TMS in a non-therapeutic way. So we're giving single pulses of TMS to map the brain. This graph, or this figure, shows a child's brain, and the rainbow on the brain represents the motor map. In those regions, we stimulate the brain over the scalp, and we find a movement of the hand. The color scale represents how strong the movement was, so yellow and red areas are where we found the strongest movements. And we found that after therapy, the motor maps got stronger and larger in our kids. We also, with Dr. Bernadette, looked at fMRI and saw that more motor areas are active after therapy than before therapy. Now, turning it back over again to Dr. Gillick.
So, from some of that, which is a glimpse of some of the work that we do, we ask ourselves, what do we know? And what we know now is that there is an influence on excitability and behavior due to non-invasive brain stimulation. We know that these children can tolerate it. They give us various feedback about this along with their caregivers, and I'll talk about this in just a second. We also know of those reported, side effects do exist. And those side effects are both serious and minor, and we'll talk about that too as well. We also can use non-invasive brain stimulation in conjunction or combination with other therapies, as are the children in one of my studies here with TDCS electrodes and constraint-induced therapy. We've seen in past work, and some of the Sentinel work by Dr. Adam Curtin, in terms of the use of RTMS, repetitive transcranial magnetic stimulation, changes in grip strength, and in my case, in one of the studies we did with RTMS and constraint-induced movement therapy, changes in bimanual performance using the assisting hand assessment. We talk to these children and get feedback as well. An adaptation of a questionnaire by Marjorie Garvey from the NIH. We look and talk to them about how satisfied are you in participating in these studies involving non-invasive brain stimulation. And in one of our studies, there was a relatively high level of satisfaction, both in the sham or placebo group for the non-invasive brain stimulation and the real. As well, a large percentage of these children stated that they would actually re-enroll in these studies. This particular study was 3 weeks long, and that 100% of them would recommend them to a friend or a family member that had cerebral palsy. We also look at these adverse events, as is in this recent review in brain stimulation on the safety of non-invasive brain stimulation in children and adolescents. And what you may not be able to see in this graph is that by using RTMS, one of the highest minor adverse events is headache. So a lot of these children complain of headache due to the RTMS. In the use of TDCS, one of the highest complaints is of tingling, specifically under the electrode sites while the TDCS is being applied. So what are we still learning? Not what do we know, but what are we still learning? Well, we're learning many things, and we chose 3 to present to you here. The first is that the motor-evoked potentials are induced at higher intensities in children than they are at adults, which leads us always to the discussion of, can we adapt an adult dose to a child? Motor-evoked potentials may not be present in children with stroke at all, using the technology that we have, nor in younger, typically developing children. So as we say to the children when we can't get a response, this is potentially the limitations of what we have with our own machines. Potentially there's movement originating from somewhere else that we cannot detect with the use of our machines. And that we also know that non-invasive brain stimulation can be used to explore neuroplasticity along with other technologies. So in these 2 pictures, one from my lab and one from Dr. Friel's lab, we're using diffusion tensor imaging or employing the use of the TDCS cortical map over that diffusion tensor imaging to seed that area and determine the integrity of the cortical spinal tract. We incorporate the many aspects of doing non-invasive brain stimulation and what it is to incorporate a child and their caregivers. And brain stimulation is just one of those pieces, as is with many of our studies, in terms of looking at the intervention and the interplay between all of the different factors that influence not only the recruitment and enrollment, but the retention of these individuals and the ability to glean that data and learn more. This is from a poster from Tanya Rich, who's a PhD student in my lab and an occupational therapist. And the feedback that we get about their involvement guides us as to not only how are they tolerating it, but how should we design future studies to be able to, again, learn more. What is not yet known? There's a lot that is not yet known. Translating, like I had mentioned before, the information we know in adults to children is tricky business, and many of you have done a lot of sentinel work and beyond in trying to do that. The figure on the right is one child in one of my studies who we used her T1 anatomical MRI, the image, to detect and try to create a computerized model to look at where the current would flow and some of the dosing parameters that we would use in a future TDCS study. There are differences between bone thickness in the skull, there are differences in myelination, there are differences in these current densities, among many other aspects that we look at in terms of that translation. Also in terms of the effects, there are many different unknowns in terms of what areas of the brain are actually being affected by this brain stimulation. We may be targeting one area, such as the motor cortex, but it's unknown if there are cortical or regional or network effects that may also be produced. There's also a concept of this unknown side effects, because the rare and subtle side effects can be just as important in terms of guiding us, and these children may not be aware of it or able to report what these side effects are. And then is the concept of long-term effects. As these children continue to develop, what is the influence of our interventions and these activities as they develop through the lifespan? And then consensus. So we do not have any tolerability guidelines at current, nor do we have dosing guidelines. We have to look at what are the optimal diagnoses for the implications and the interventions with these forms of brain stimulation, the comparable protocols, and then sharing our outcomes is important as well. So here, as Dr. Fowler has mentioned, is one form of TDCS that's already out and being used in the market. It has its own package, it has its own battery pack, and people are using this to augment, or potentially augment, things such as gaming, sporting ability, and cognition. This individual is at work. And actually, I was speaking at a New York City neuromodulation conference, and I got on the subway, and an individual next to me was wearing a TDCS unit playing a game on his phone. And I wanted to sneak a picture of him just for this very conference, but I couldn't. So is non-invasive brain stimulation a disruptive change agent? We say yes. If something was thought of, but it hasn't even been tried, it's just as much of a disruption. It disrupted me to be on a subway and see somebody wearing a TDCS unit. Why did it disrupt me? I had to ask myself. What particularly about this? How much has it been studied? As a researcher, I'm challenged by these things. As a therapist, I'm even more challenged. There is some evidence that TDCS and rTMS has some worth, so it's worth the exploration. And if it's tried and it's found to be statistically insignificant, then the scholarship in this area can be transferred to another disruption to further this important cause in our cerebral palsy therapies. But the new normal will only work if the outcomes will show us that this is safe and efficacious. So if we have the same outcomes in the use of non-invasive brain stimulation, well, then we have a new way of doing things. But if we have better outcomes, then the safety and improved functional risk is worth that potential reward. When I stand here in front of you, I represent many, and I know many of you in other domains feel the same way. We need to be responsible pioneers in these new frontiers in pediatric brain stimulation. Safety is paramount. We have a duty to define what we are doing. We have a duty to share our results, to share our side effects, to share what data we have with the larger community and with each other. And we have a duty to educate each other, as we are doing now here at this conference, and the families that participate in our studies. We're going to show you a very quick video here in terms of children participating in Dr. Friel's lab and their interpretation of what it is to be a part of our studies.
TMS, it's pretty high because you have to sit still.
It's very simple actually. Many people think it might be scary because you get like wires attached to you, but that's not scary.
Sometimes you would twitch too when it was stimulating the brain.
Some of the tests you get to take your shoes off, and it's the best. It's actually called neuroplasticity. New pathways can be recreated over older ones, and it gets hands to improve, and the new pathways can arise. No, it does not hurt. It's more like a tingling feeling. You said it never hurt. It said it kind of tickled a little bit or something like that.
No, like I was never afraid of these tests. Like I was all like, okay, whatever, I'm doing it. I get paid for this.
Just feel like a kick, but it's not really hurts. It's just like, but like the first time you get a bit startled.
Another $20 for my piggy bank.
Thank you, Sherry Kuo, also for being a part of that. We showed you in there. So we want to thank everyone. We want to thank the Academy. We want to thank you, Dr. Fowler, for the invitation to be here today, and to all of the children who participate in our studies and the families that support them as well. Thank you.
Thank you for that excellent presentation. And I think that also Dr. Friel's work is just a fabulous example of translation from the basic animal work into humans, which is just wonderful to see. So we have some time for questions. We can have people come up to the mics, and then also I'm going to start with Gilda. Do we have an app question?
No.
No! You all stopped using your app. You were all just so mesmerized by the speakers that you forgot you had an app?
People used the app. They mostly said, wow, this is cool.
Wow.
They took photos, but there weren't any questions.
Okay. Well, we'll wait a minute. We do have a question over here, and then we are going to have all of our speakers go to the speaker corner after the session, so that if you're kind of shy, either electronically shy or shy to come up to the microphone, then you can have a more private discussion there. So please go ahead and ask your question.
Hi, Christopher Lunsford, University of Virginia. So with the TDS that you saw on the subway with the person gaming or I saw the picture with someone about ready to play a sporting event, does the future in your mind look like something like that could give an unfair advantage, or is that going to be part of a training process? What would your thoughts be on that?
So I was just interviewed by PBS NewsHour, and they asked me a very similar question. And what I said to them is, I don't think there will be TDCS maybe in 5 years, maybe in 10 years. I think we will go further than that in terms of understanding optimal opportunities for neuroplasticity. And that got twisted a bit in terms of the response that came out in terms of the interview. But what I mean is similar to what Dr. Merzenich said yesterday, that we're going to have to find out when the critical period may be. And if we're talking about something like gaming or cognition or sporting events, will it really have an effect or a lasting effect is a question I think we really need to answer before we're able to say the marketability is there. So I think it will be something different, if you ask me. I think we're just at the very beginning of this journey in terms of understanding applicability.
You have a question over here?
Michael Masal, University of Chicago. Excellent presentations by everyone. I have a question for Professor Spittle. Your measure of ends seems to pick up the high-risk group where regulatory abnormalities and regulatory behaviors are a major pathway to cognitive disability in preterm infants. And that's been the third rail of neonatal outcome studies because we're so much better on predicting motor, especially white matter injury, and cognitive has been very difficult to predict. Does this suggest to you that there are some ways of potentially intervening on regulatory behaviors, knowing like some of the limitations to date of some of those studies, small numbers, underpowered, not as diverse, but also some preliminary things that are exciting. Does that suggest some interventions you might want to do in high-risk cohorts?
Thanks, Michael. There's actually quite good evidence for infants who are born preterm to do early developmental interventions, and a lot of those interventions are focusing on the parent-infant interaction and actually helping parents to help with regulation of their babies. So I think it highlights the importance of trying to identify those infants more early and targeting those infants, but there is some evidence there where at the moment Dr. Carly Trevaux, who works in our research team, is looking at a web-based intervention program targeting parents to work with their children at home to try and help with regulation. And we're trying to do a web-based program so that we can target more infants rather than having them come into a hospital-based setting.
Yeah. Rosemary Trout-White, who's at University of Wisconsin, Milwaukee Children's Hospital, has work done on engaging the parents in the beginning in the nursery, especially for these late preterm and moderate preterm, and has not only impacted on family engagement, but trajectories of weight gain and trajectories of development. Pilot work, RCTs have been involved, but I would encourage people to critically look at that, and that's an important area for exploration.
Absolutely, and I think the moderate to late preterm group has been one that's been a bit neglected because they're at less risk, but they still are at risk. Thank you.
Okay, we have a question over here, and then we'll go back over to there.
Hi, I'm Laura Shamblin. I'm a general pediatrician. I have a question for Dr. Fetters. I noticed all the interventions were not things that people could really do at home. They were just done in a lab. And I was wondering if you have any suggestions of things that people can do at home right now. I know there are toys with buttons and lights and things, but are there other things involving movement that you could suggest?
Yeah, I think using the idea of contingency, you've already suggested some simpler ideas. The adaptive car that the little girl was activating is a simple activation toy. So I think there's lots of toys that are currently on the market that are contingency based. They're not necessarily exploratory based, if you will. So there's not a lot to discover In some of the experimental paradigms we looked at, the early kicking work, the infant was tethered. And so you had to discover that your leg could pull on the string and make the mobile move. But that's a fairly limited discovery. So I think looking for toys at home and consulting with the therapists about what is this just right challenge for your child, and how can we design something that's contingency-based that requires them to explore and to problem solve. And I think that's where the real challenge for physical and occupational therapists lies, is designing and discovering those. I don't think they all have to be gadgets and technology. I think the gadgets and technology are helpful in terms of the amount of practice that we need. We need alternative ways, in addition to one-on-one problem solving with your child, we need alternative ways to increase the practices at home.
Dr. Murphy?
Yeah, thank you. Excellent talks. Kevin Murphy with Gillette Children's. Just a question for Dr. Gillick or Friel. If you look at some of the literature on electroconvulsive therapy over time, there's a lot written up on cognitive and memory loss for those that are repetitively exposed to that. The transcranial stimulation seems much more friendly than that, but I'm just wondering over time if you're kind of looking at some of the cognitive and memory issues that have shown up with at least somewhat comparable stimulations in the electrical world.
Thank you. I'll jump in. So we actually have a poster on this. We did a long-term follow-up 2 to 4 years after the RTMS CIMT study. And in terms of the cognitive and memory domains of which you're speaking, we used some of our original questionnaires and interviews to try to assess that. We also reviewed the medical records and had our medical team doing assessments as well. So in specific to that, we didn't run a battery of tests, but it is a concern of ours, and we incorporate that in terms of our pre-testing sessions. It's difficult, of course, to do a long-term follow-up in any domain, in any type of research, but it's worthwhile because we don't know what the potential influence could be long-term for these children in the many different ways and systems that we should be evaluating. So thank you for that question.
Okay, we're going to take the last two questions over here as well.
Thanks. John Sullivan, pediatrician, Northern California. Just scientifically, how large an area of the cortex is actually stimulated or recorded by the techniques that you use?
It depends. It depends upon which form you are using. So, and it also, so if I say it from the mechanistic standpoint, it could be something from 0.5 centimeters to 10 centimeters in terms of the potential spread. But it could go beyond that because it could also be, of course, influencing not only the motoric network, but other supplementary motor areas, and not to mention sensory, and then the deeper subcortical structures as well. So that's the component in using such modalities as resting state fMRI, or trying to look at other ways of doing it. Someone had presented some MEG studies to look at what are we doing both spatially and temporally to understand this, not only from the most immediate effects, but also from a network perspective.
So the spatial area is pretty big.
It is actually very big.
Okay, we're going to take one last question.
Hi, my name is my name is Lori, and I'm a parent of a child with CP. And thank you for your presentation. As a parent, you research everything, and there's a guy named Yuri Danilov who does tongue stimulation, I think, in stroke patients. And I was just wondering, in the context of your talk, if you could comment on is that too disruptive in your talk? Is he too much of a disruptive change agent because it's not considered mainstream? And I did write to him, and he said he wanted to do something for kids with CP, but there wasn't the right research set up. So just if you could comment.
Could you just clarify what type of stimulation did you mean?
Sorry, tongue.
Oh, tongue. Yeah.
Thank you for your question. Sorry. So we're definitely interested in looking at whatever kinds of stimulation can help kids. As far as I know, there's no studies of tongue stimulation in kids, and I'm not sure the mechanism of how that works. affects the brain. But I think as a field, we need first of all to be open to different ideas and different approaches, but also we need to know, we need evidence that can help. So I think our first step for that type of solution is to find out if it can really help. So I hope that helps.
Yeah, and I would add that literature, for instance, in spasmodic dysphonia, that those are some areas of exploration that have begun in the adult populations, but I too don't know of any, particularly in pediatrics, that have been explored in that domain. Thank you.
Okay, and I'd like to thank all of our speakers for these wonderful lectures. Thank you.
Thank you.
Thanks so much.
Oh, okay.
I don't know. Do I have my mic back? If everybody could please just wait a few more minutes. We do have an award to present, the Duncan Wyeth Award, and then we just have just a brief update that you all want to hear about for the European meeting that's going to be our first international meeting. So it's just going to take a little bit longer. Sorry about that. I think that there was a miscommunication. So next we're going to be presenting the Duncan Wyeth Award. And this award honors Duncan Wyeth, who was both an outstanding athlete and advocate. The award goes to an individual who promotes sport or recreation in their area for individuals with disabilities. The recipient may be an athlete, coach, or a sponsor. So now I'm going to ask the chair of the Adaptive Sports Committee, Dr. Keiko Shikako-Thomas, to come up to the podium and present this award.
Great. So it's a great honor to present the Duncan Wyeth Award this year to Wendy Frick. And I think I'm pronouncing right, did I? Okay. So Wendy is a horsewoman, and I checked, this is right, a horsewoman, such a nice title. And she's also a wife, a mother of 2 amazing daughters. And she also happens to have spastic hemiplegia, something that we learned over lunch, that she only learned that CP is what she had at age 19. Before that, all she was told by doctors was, go out there, do your best. She took that seriously, and actually she had a lifelong love for horses, and she started riding in her late 30s. She has since hidden in varying disciplines, such as hunter, jumper, 3-day eventing, dressage, and para-dressage. She has actually represented the U.S. In international competition at the World Equestrian Games in Kentucky in 2010. And currently she's training a new horse, Cabana Boy, and she's also completing a program to become a recognized dressage judge. Wendy was chosen by the Adaptive Sports and Recreation Committee as a great example of a role model of going out there and doing your best and exceeding in a sport that is very challenging. And so it's our pleasure to give this award to Wendy.
Thank you so much.
Thank you. And she has beautiful boots on. Now, those are really a horsewoman's boots. Okay, so last but not least, we have Dr. Jens Bo Nielsen from the University of Copenhagen in Denmark, who's going to talk to us about the European Academy of Childhood Disability and give us an update on their meeting. Professor Nielsen is Professor of Human Motor Control at Department of Exercise and Sports Science at the Department of Neuroscience and Pharmacology, the University of Copenhagen in Denmark. And I had the pleasure of attending their meeting in the spring, which is just a great meeting and a beautiful city.
Thank you very much. I'm grateful for this opportunity to do a little bit of promotion for the European Academy. I'm going to basically tell you a little bit about the past, present, and future. The past is what I was responsible for, the meeting in Copenhagen in May. The present meeting, or the future meeting, basically next year, 2016 in Stockholm, and then in 2017 in Amsterdam, which is as far as we have planned so far. So the meeting in Copenhagen, basically what we tried to do was to zoom out a little bit and sort of say, what can we do if we try to look at the big picture and try and find some new ways to help children with cerebral palsy in the most efficient way. And we found 4 main focus areas that we wanted to work with, and those are the ones that we've listed there, and which sort of was the core of the meeting. And this is, I think, a good way of focusing on the kind of research that we want to help use to help children with cerebral palsy. The weather was nice, which is rather unusual in Copenhagen, so we had a bit of luck. I was hoping when I came here that you would also be in luck here, but the weather so far hasn't been as nice. The meeting is wonderful, so I'm really pleased to be here. And I cannot really begin to express how wonderful it is to attend the Congress without having the responsibility for it. So I feel with Eileen. We had one special thing in Denmark, which is that we have a royal family, so we also had the royal family visiting us during the conference, which is also lifting things up a bit. So there are some pictures from that. The statistics, basically, just to give you an impression of what the meeting is all about. So we have usually around 600 participants, usually from quite a number of different countries all over the world. The next meeting in Stockholm is expected to be quite a lot larger because it's also a joint meeting, but you see it there. The reviews were extraordinarily good, as you can see. 97% would like to attend the next EACD conference, which is nice for the people in Stockholm. They will recommend it to their peers, etc. And a little bit stunning that 50% found that the meeting exceeded their expectations. They could have very low expectations to begin with, but anyway. And the remaining found that it lived up to their expectations. So we were pleased, but in all studies of this kind involving statistics, we have to realize that it was underpowered and it was probably also biased, because as usual, those who respond are the ones who either found it very good or very bad. So we were probably also lucky on that account. I would like to mention briefly the Helena Elsa Center, which funded quite a lot of the meeting, quite substantially. It is an extraordinary place. It's coming from a private foundation which has been putting money into research in cerebral palsy during the past 10 years and really has been a game changer in Denmark and putting cerebral palsy research on the agenda to a very large extent. I would like also to mention that during the meeting we had a presentation from 2 people here, Jakob Nassel and Christian Molke-Martini, because they've been working on a quite extraordinary project for the past 2 or 3 years. Christian is a philosopher and has been following Jakob for quite a long time and is using Jakob to a large extent as part of his philosophical thoughts. I'm not very much into it, so I cannot explain exactly what it is. But as part of this project, they have also had a film team following Jakob for more than a year and documenting his life, basically. And also as part of that, he set up a play at the Royal Theatre last year, and that was also documented as part of this film. just prior to that, unfortunately, Jakob had a traffic accident. And this is, I think, in many ways, part of what is really interesting in this film, because this is the first time that he realized that there was something wrong with him, something bad. He has been suffering from cerebral palsy all his life, but this has been part of him. Now that he had a traffic accident, which made him handicapped, he suddenly realized that this is something new, something that is not me. And there is that huge difference, which is documented here. I'm not sure whether I can actually start the... it's a short trailer. The film came out last week, has already received quite a lot of nominations for different awards. So I hope it will... No, it wouldn't work. I go back one.
Can you start the video from back there, Steve?
My mother always told me that a big part of my brain is missing.
Det er din del her, som du mangler. Jeg er tyk og grim, derfor får jeg ikke nogen kone. Du er spasser, derfor får du ikke. Det er ikke en rar verden, det er en hård, brutal verden, som vi lever i.
Okay, in my hunt for normality, I'm producing a play at the Royal Theatre. The play is based on my experiences in the real world. Will my kind exist at all in the future?
Jakob var jo ude for en trafikulykke i sidste uge.
Hvorfor er det dig, der går ud foran en bus?
Så vi er ligesom nødt til at udskyde premieren.
Du er en yndling. Han kommer. Hvorfor er det, du død og pine vil gøre det, der er allersværest for dig selv?
Jakob har fået lov til at gennemføre forestillingen med den betingelse, at han ikke laver alle scener.
Her man ikke ønsker sig Jakob om at have en pause fra virkeligheden. Jamen, det er da lige meget, hvad de synes. Det der handler da bare om at skyde på, hvad de synes, Jakob. Det skal komme herindefra. Det skal betyde noget, det du skal lave.
So the meeting in Stockholm is taken care of by Ann Christian Eliasson. It's quite well progressed already, and unfortunately it's no longer possible to send in abstracts, but you can still register. It is going to be a joint meeting, so it's both a meeting of the European Academy of Childhood Disability, but it's also an international conference, and it's the first joint meeting between the American and European societies. It's going to be in a very nice conference hall in the middle of Stockholm with all wonderful facilities. 800 abstracts have been submitted, 14 keynote presentations, 32 team presentations, and the abstract review process is going on right now. There's going to be some pre-Congress symposia, and finally the Amsterdam meeting is also being planned in 2017, the 17th until the 20th of May, and again in a very lovely place, wonderful conference center, and of course with interesting scientific program and of course also in a very lovely surroundings. So there are some websites that you can go to if you want to have more information. Thank you very much.
That now concludes our session. Thank you.